Welcome. We're going to solve test number 2 in order to help you prepare for the retake. Okay, this was the test that we took, and I'm going to go ahead and solve each problem to help you understand how to solve each one of these problems step by step. The first set of problems says write the domain for the following rational expressions. And basically you have here a fraction that has a trinomial on top, trinomial on the bottom. All you have to do here is focus your attention on the bottom. If you notice on the bottom, I have a trinomial. So you ask yourself, what number gives me 10? The numbers are 1 and 10, 2 and 5, and that's it. Out of these two options, which one gives me 3? The right answer is 2 and 5. So in other words, this denominator will be able to factor as x2, x5. Okay, now that I've done that, I focus my attention on the middle term. And I look at the biggest term and I say, what is the sign of the biggest should be? It should be the same as the middle term, so it would be negative. And if this is a negative 5 and I want to be a negative 3, then negative 5 plus 2 or minus 2 gives me negative 3. The answer is positive. Okay? Alright. So, with that in mind, with our denominator now factor, all I have to do is do my domain, which basically means what numbers will make the denominator 0. So I want to set this guy's here to be different than 0. So how do I do that? I'm going to split into 2. X plus 2 must be different than 0. And x minus 5 must be different than 0. Okay, now with them, I need to solve for x. To solve for x, I need to move the 2 to the other side. So that means the 2 is going to become a negative 2. And if I do the same thing with the negative 5, the negative 5 becomes a positive 5. So this tells me that the denominator cannot equal negative 2 nor 5. So I'm going to write my answer as x belongs to all real numbers. X could be any values of on the real numbers, with the exception of x cannot equal negative 2 and x cannot equal 5. And that's it. See, if you notice, I didn't even do anything on the top. I don't have to do anything on the top. Okay? Same goes for the bottom here. I don't have to worry about the top because all I'm doing is finding the domain. Basically, I'm looking for the values of x that will make this denominator 0, because we cannot have denominator equal 0. If I put my attention on the denominator here, there's nothing that I can factor, so I'm going to go ahead and set it different than 0. And now all I have to do is solve for x. So I'm going to move the 1 to the other side. So it becomes a positive 1. And then I divide both sides by 2. So in other words, x must be different than 1/2. So this would be x belongs to all real numbers, such as that x must be different than 1/2. Okay, and that concludes these types of problems. Okay, and on your retest, you should expect to see 2 problems like these. Okay, again, just focus your attention on the denominator. You want to make sure it's first to factor, and then set your factors to different than 0. And that's basically what I did. Okay. All right, now let's proceed to the next set of problems, which says simplify, and it's missing the y there. Simplify and then identify any x values for which the expression is undefined. Okay, so that means always, okay, on these types of problems, you're going to do two things. Okay, the first one is you're going to try to factor every member of the fraction, and then after you factor, you're going to try to cancel things. Okay, a lot of times I notice that students try to cancel, but they never try to factor first. So always remember, you need to factor. So look at the number on the top, the numerator, and ask yourself, can I factor this? Is there a number that goes into 2x and 10? And the answer is yes. I can factor out a number 2. And if I factor out a number 2, 2x divided by 2 becomes x, and negative 10 divided by 2 becomes a negative 5. And then on the bottom, there's nothing I can factor, so I just write x minus 5. And then these two cancel. This equals 2. Okay, so I have simplified. So if you notice, first thing I did, I factor. There's nothing I can factor on the bottom. So I'm done factoring. Now I proceed to cancel. I notice I can cancel these two. My final answer is a 2. Now this one I also have to do my domain. Remember, domain, you just focus on the denominator, on its factor form. In this case, there was no need to factor the denominator, so my denominator is x minus 5. And then you take your denominator and you set it to different than 0. And all you have to do is make sure x is alone. So we're going to move the 5 to the other side. It becomes x different than 5. So this would be x belongs to all real numbers, such as that x must be different than 5. Okay? And that concludes our problem number 3. Let's go ahead and go to number 4. Okay? Again, keep in mind, factor and cancel. So, we'll look at the very top and I say, can I factor this? Well, it ends with a 2, so I put 1 and 2, and there's nothing else that gives me 1 and 2. Question is, 1 and 2 will give me a 1 right there, and the answer is yes. So that means the first trinomial, the one on the top, can be factored as x1, x2. Okay? And now that I put the numbers there, I look at the middle term, the biggest digit, which is 2, right? Because I have 1 and 2. The biggest one should always have the same sign as the middle term. In this case, it's positive, so I put a positive there. And then I ask, positive 2 plus 1 or minus 1 gives me 1x over here. And the answer is minus 1, because 2 minus 1 gives me 1x. Okay? Now I'm going to proceed and do the same thing on the bottom. My last number is a 3. What numbers give me 3 is 1 and 3. So I open two sets of parentheses. I put x and x, 1 and 3. Again, sign of the biggest is the same as the sign in the middle, so it would be positive. And positive 3 plus 1 or minus 1 will give me the positive 2 here. The answer is a negative 1. So what have I accomplished so far? I factored the top, I factored the bottom. So I accomplished that first objective, which is to factor. Now I'm ready to move to my second objective, which is to cancel. So if I notice here, I can cancel the x minus 1 and the x minus 1. So that means my final answer will be x plus 2 over x plus 3. And that is the answer to this problem. Okay, we also need to remember we have to do our domain. So how are we going to do our domain? We look at our denominator in its factor form. So here's my denominator. Then I factored. So my denominator was equal to x minus 1, x plus 3. Okay, and I set it to different than 0. If you notice, I'm using the x minus 1 that I cancel. Remember, domain is just the bottom. A lot of times I see students using these two because they're the ones left over. No, the domain is the numbers on the bottom before you got canceled. Okay, all you have to do is take this guys over here, set it aside, and set it to different than 0. Once you set it different than 0, then break it apart. X minus 1 is different than 0. X plus 3 must be different than 0. Now that I have that, let's solve for x. X must be different than 1. And x must be different than negative 3. Okay, all I did is move the numbers to the other side. Remember, when you move sides, it will change the sign of the number. Okay, now that I have that, you always begin the domain by saying x belongs to all real numbers such as x is different than 1 and x is different than negative 3. Okay, so that concludes the problem number 4. Okay, let's go ahead and go to problem number 5. And I went ahead and wrote again our objective, which is to do these two steps, which we always have to have it in mind. So when I look at problem number 5, I look at the top and I ask, can I factor anything? And the answer is no. That's okay. Just write it down. X plus 4. Okay, then I look at this guy over here and I ask myself, can I factor? Well, yes, we can. We can try. We need to remember, this is not a 1. All the previous problems up to now had always a 1 in front, which is is easier because all you do is look for the factors, the numbers that give you that last number, and then you open the parentheses and put those numbers there. Now, because I don't have a 1 over here, we're going to have to take a few extra steps to get to the answer. So let's see how we do it. First of all, because this is not a 1, you multiply. 3 times 4 is 12. So you're going to make a list of numbers that give you 12, which are 1 and 12, 2 and 6, 3 and 4. And I believe that's it. That's all the numbers that multiply give me 12. Now I want to know which number, when added or subtract, is going to give me the 11. So if I notice 1 and 12, if I subtract 12 minus 1, that will give me 11. So I know that's my numbers that I want. So what I'm going to do here is I'm going to copy the first term over here, 3x squared. I'm going to break this 11 as 1x and 12x. And I'm going to copy the last number. Now I need to decide what are the signs going to be over here. Just like before, the sign of the biggest will have the same sign as the middle term, which happens to be positive 11. So that means my 12 will be a positive. Now you ask yourself, positive 12 plus 1 or minus 1 gives me 11. And the answer is minus 1. Alright, so copy the first, break down the middle, copy the last. Now you need to group it. The first two and the last two. The first two. What can I factor from these two? The answer is x. I can factor out an x. If I do that, 3x squared divided by x is 3x. Negative 1x divided by x is negative 1. Then you proceed for the the next two. Look at this sign right here is a positive, so you bring it down, positive. One number goes into 12 and 4. The answer is 4. 12x divided by 4 is 3x. Negative 4 divided by 4 is negative 1. So, now that I have that, I have two terms. They both have something in common, which is they both have 3x minus 1. So I'm going to factor that out. I'm going to take that out, put it outside. So 3x minus 1 is what they have in common. And if I was to remove that 3x minus 1 from both terms, what am I left with? Well, I'm left with the x and I'm left with the 4. So I put that on the second parenthesis, x plus 4. Okay, so now that I know them, I'm going to move to over here my factors, which are 3x minus 1, x plus 4. So this was my denominator. This was all the process I did to get my factors, and then I put my factors there. If you notice, this took a little bit, a few extra steps to get to the factors. That's the difference between not having a 1 here and having a 1 there. Because remember, when you have the 1 here, you found your factors over here, and basically you open two sets of parentheses, and voila, you had your factors. Just two very simple steps. Because I don't have a 1 here, I had to take a couple extra steps to get to those factors. And that's what I notice sometimes students miss. They go from here to here and they don't put and they get the numbers wrong. So please be careful. Okay? Alright. Now, what we accomplished so far now is to do our first objective, which is to factor. We factored the top, nothing could be factored, so we just copy. We factored the bottom, and here are my factors. Now we're ready for the second objective, which is to cancel. And if I notice, I have an x plus 4 on top and an x plus 4 on the bottom, so that can cancel. Okay, when I cancel everything on the top, what am I left with? A 1. Okay, so just remember, you can think of it this way. There's a parenthesis there. Is there a number here in front? Yes, there's an invisible 1. If I cancel the x plus 4, that 1 must become visible. Okay? And on the bottom, was there anything not canceled? Yes, there was. 3x minus 1. So that's my answer. A common mistake on this problem was that many students forgot to write the 1 on top. So they lost points for that question because of that. Not a lot, but some. So try to avoid forgetting to write that 1. Okay? Alright. Now our job is to do the domain. If you remember domain, you need to look at the denominator in its factor form. This is our denominator. We factored. So this is the factor form. So you take the factor form, you write it to the side. Right there. And your job is to set it different than 0. And you break into two parts. 3x minus 1 must be different than 0. And x plus 4 must be different than 0. Now all you have to do is solve for x. So move the 1 to the other side, becomes 3x different than positive 1. And I want the x alone, so I'm going to divide it by 3 on both sides. So x must be different than 1/3. That's one of my domain answers. And the other one is I move the 4 to the other side, so x must be different than -4. So here I will have x belongs to all real numbers, such as that x must be different than 1/3 and x must be different than -4. And that's my answer. Okay? Okay, so this concludes the first page of the test. I hope I was able to be clear here on the things that you're expected to do. Cannot emphasize enough, please first factor and second cancel. Okay? Alright. Welcome back to the second page of this test retake. Okay, we're going to go over the answers again, like I said. So let's go ahead and proceed for problem number 6. Again, remember the two steps or the two objectives that we want to accomplish, which is first factor, and then number 2 is to cancel. You always keep that in mind as you approach these problems. Okay, we're still trying to simplify and write the domain of each problem. So as I approach this problem, I look at the very top of the fraction, 3x plus 4, and I ask myself, can I factor that? Is there a number that goes into 3 and 4? And the answer is no. So that's okay. We just copy 3x plus 4. On the bottom, I need to know if I can factor. If I notice I have a number other than 1, so I come here to the side and multiply 3 times 4 is 12. And this will be 1 times 12, 2 times 6, and 3 times 4. These are the numbers that will give me 12. And I'm looking for the number 1 right there. So which one gives me a 1? The answer is 3 and 4. And just like the problem before, because this is a 3 and not a 1, that means I will need to copy the first term. I'll break apart the middle term as the factors that I found, 3x, 4x, and I copy the last term, which is negative 4. Okay? Now, the biggest digit is supposed to have the same sign as the middle term, so that will be a positive 4. And positive 4 plus 3 or minus 3 give me a positive 1. The answer is negative 3. Okay. Now I am going to group them. What number can I factor from the first two? Well, I can factor out a 3, as well as I can factor out an x from each term. So I'm going to go ahead and do that. 3x squared divided by 3x equals x. Negative 3x divided by 3x is negative 1. Next one is, what can I factor from 4x and 4? The answer is 4. So 4x divided by 4 is x, and negative 4 divided by 4 is negative 1. Okay, and now I try to see what can I factor from these two terms, and the answer is x minus 1. And what do I get left? If I factor the x minus 1, I'm left with 3x and a 4. So I write it down, 3x and a 4. Okay, now that I have factored this, I'm going to proceed and copy it there. So what I've accomplished so far is I tried to factor the top, I couldn't, so I copied. I factored the bottom, and here it is. Now I'm ready to cancel, and we see that we can cancel the 3x plus 4. Again, if everything on top is canceled, you write a 1. And on the bottom, we see that we have left x minus 1. So please remember to write the 1 on top. Okay, now we need to do our domain, which is x belongs to all real numbers, such as, now we look at the denominator in its factor form before it got canceled. So this would be x minus 1, 3x plus 4, and we set it to be different than 0. We break it apart into two parts. X minus 1 must be different than 0. 3x plus 4 must be different than 0. Solve for x must be different than 1. And here, this would be 3x must be different than negative 4. We divide both sides by 3. That means x must be divide both sides by 3. That means x must be different than negative 4/3. So basically I'm solving each one for x. And now once I have the answers, I write these answers as part of my domain. X must be different than 1, and x must be different than negative 4/3. So that concludes our problem number 6. Now we're going to go ahead and do problem number 7. Okay, again keeping in mind our objectives, which is first to factor, and then second to cancel. Okay, so when I look at this problem here, I focus my attention on the top first, and I ask myself, can I factor anything? Well, I notice I have an x on both terms, so let's go ahead and factor that. I also notice there is a negative in the front of x squared. Okay, we usually want that to be a positive, so we're going to go ahead and factor a negative there. And what that does is going to force that first number there to be a positive. So negative x squared divided by negative x makes this an x, and that's what we want. And then positive 3x divided by negative x becomes a negative 3. So I factored the top. Okay. On the bottom, I notice I have a number other than 1, so I multiply 2 times 3. 2 times 3 is 6. And what numbers give me 6? 1 and 6, 2 and 3, and that's it. Out of these two options, which one will give me the 7 there? The answer is 1 and 6. So now that I have that, 1 and 6, I'm going to come over here, copy the first term, which is 2x squared. I'm going to break down that 7 as 1x and 6x, and I copy the last term, which is positive 3. Okay, sign of the biggest is supposed to be the same as the middle term, so it will be negative. And then negative 6 plus 1 or minus 1 gives me a negative 7. The answer is a negative 1. So I look at the first two terms, and I say, what can I factor from these two terms? I can factor out an x. If I factor out an x, then this would become 2x squared divided by 2x is 2x. Negative 1x divided by x is negative 1. And then over here, I'll have, what number can I factor from, first of all, there's a negative there, so let's put a negative here. And then what number can I factor from 6 and 3? Answer is 3. So negative 6x divided by negative 3 gives me a positive 2x. And positive 3 divided by negative 3 gives me a negative 1. And we should expect to see something in common. And we do see that, 2x minus 1. So that means we're going to factor that out, 2x minus 1. So that means if I remove the 2x minus 1 from both terms, what I'm left with x minus 3. So that's what we're going to be on the second parenthesis. Okay, so I factor from here to there. So I'm going to copy that over here. So this would be 2x minus 1 times x minus 3. Alright. So what I accomplish is I factor the top and I factor the bottom. Sorry. I factor the top and I factor the bottom. So now I'm ready to cancel. So I notice I can cancel the x minus 3. So that means I'm left with negative x on top, and on the bottom I have 2x minus 1. So that's my answer. Now don't forget, we need to do our domain. So domain always begins with x belongs to all real numbers, such as, now we need to find our restrictions. Where do we find that? Again, our denominator in its factor form before it got canceled. In other words, 2x minus 1, x minus 3. Okay, this is our denominator in a factor form before we cancel. So we take that and we set it to different than 0. We break it apart into two parts. 2x minus 1 must be different than 0. X minus 3 must be different than 0. We now solve for x. So this would be 2x different than 1. Divide both sides by 2. X must be different than 1/2. Here, move the 3 to the other side, so it'll be x must be different than 3. So now I'm ready to write in my domain, which is x must be different than 1/2 and x must be different than 3. And that's the answer for our problem. Okay, now we're going to continue to the next set of problems, which is multiply and divide. And the problem says assume that all expressions are defined. Whenever you see that, the problem is telling you don't have to worry about the domain. All you have to do is those two objectives. First, factor, and then second, cancel. Alright. Good. So when I look at this, I need to ask myself, can I factor this guy here on top? And the answer is no. So just copy it down. Can I copy the bottom? Can I factor the bottom? The answer is no. So just go ahead and copy it down. The number on top is over here. Can I factor something? Yes. I can factor out a 2 from both terms. So go ahead and put a 2. And 2x divided by 2 is x. Negative 6 divided by 2 is a negative 3. And on the bottom, can I factor anything? The answer is no, so just copy. So what I accomplished so far is I went through every single term here, and I asked myself, can I factor? So can I factor this? No, so copy it down. Can I factor this? No, copy it down. I could factor the top, so I factor, wrote what I'm factoring, and wrote what my resulting binomial is. And then on the bottom, can I factor? I could not. So I'm done with problem step number 1, which is to factor. Okay, now I'm going to try to cancel. So I noticed I have x minus 3. X minus 3 can be canceled. So what am I left with? I'm left with a 2 times x minus 2 over x plus 5. And that's all I can do to cancel. So that's my answer. That's it. Okay. The next set of problems are monomials. Okay, so basically there's not really I can factor anything here. So I'm going to go ahead and start to cancel things. Okay, so in this one, I see the 20 and the 15, so I know that 5 goes into 15 3 times, and 5 goes into 20 4 times. Okay, I also notice if I have a 2 and I have that 4 that I got here, so I'm going to cancel that 2, becomes a 1, and that 4 becomes a 2. Okay. Alright, with the letters, sometimes it's best to multiply on top and then multiply on the bottom and then do the division last. That's what we're going to do. We have a 2 here, so we're going to write the 2 in the front. And we have x to the first, x to the 7th. What do we do with the exponents when we multiply? We add the exponent. So this would be x to the 8th power. On the bottom here I have 3 times 1, gives me a 3. And I have x to the first, x to the 4th. So if I add those, the exponents this would be x to the 5th. Okay, now we're going to do what I was telling you. We're going to do the division. And since I have an 8 and a 5, and the 8 is bigger, that means the x is going to stay on top. 8 minus 5 is 3. And that's our answer. Okay, and then here we have our last problem. Okay, we have these numbers here, so let's see if we can cancel. I notice I can cancel the 3 with the 9, because 3 goes into 3 one time, 3 goes into 9 3 times. Also, 2 and 10, 2 goes into 2 one time, 2 goes into 10 5 times. So that means on top I'm going to get the big 5, and on the bottom I'm going to get 3. 1 times 3 is 3, 1 times 5 is 5. Now I'm going to deal with the x's and the y's. I'm going to multiply just the top ones, and then I'll do the bottom ones. If I multiply the top ones, 5 plus 3 becomes 8. And y to the third times y to the fourth, you add the exponents, so it would be y to the 7th. And I do the same thing on the bottom. X to the third times x to the second gives you x to the 5th. And y to the 7th times y to the 5th gives you y to the 12th power. Very well. Now, we still have 5 over 3. And notice the x is bigger on top, so this would be x to the third. And I also notice the y is bigger on the bottom, so that means the y stays on the bottom. 12 minus 7 is 5. So that means this is be my answer. Okay, so this concludes page number 2 of the test retake. Okay. Okay, now we're going to continue page number 3 of the test retake, and here we face with problem number 11. Again, keep in mind the steps, which is first factor, and then second cancel. Okay, when I look at this problem, I ask myself, can I factor the first one, x minus 2, and the answer is no. So I'm just going to copy it. Same question on the bottom. Can I factor anything? The answer is no. So I just copy. Okay. Times. Can I factor anything on the top? The answer is yes, at 2. This becomes 2x minus 3. And on the bottom, I see I have an x squared minus 4. So what I'm going to do is I'm going to add a 0x. So this becomes x squared plus 0x minus 4. So I ask myself, what numbers give me 4? The answer is 1 and 4, 2 and 2. And the question is, which one is going to give me a 0? The answer is 2 and 2. So it would be x2, x2, sign is plus. So plus 2 minus 2 or plus 2 gives me a 0. The answer is minus 2. So in other words, x squared minus 4 is factored into x minus 2 times x plus 2. Very well. Now we did that. We have accomplished step number 1, which is to factor everything that is possible to factor. We did that. Now we're going to proceed to try to cancel. I notice that I have a 2x minus 3, 2x minus 3. That will cancel. X minus 2 cancel with x minus 2. So that means I'm left with a 2 on top and an x plus 2 on the bottom. And that will be my answer. Okay. Okay, so we're ready to proceed for the next problem, which is problem number 12. And again, we ask the same questions. Can I factor anything on the top? And the answer is yes, I can factor out a 10. 10x divided by 10 gives me an x. Negative 4 divided by 10 gives me a negative 4. Over here, I have a trinomial, so I take the last number and I break it down as 1 and 8, 2 and 4, and that's it. And I'm looking for a number 6, so that means 2 and 4 will be my numbers. So it would be x, x, 2 and 4. Okay, sign of the biggest is the same as the middle term. and then negative 4 plus 2 minus 2 is going to give me the negative 6, and the answer is the negative. So come here and write my factors. Okay, so continue factoring. Can I factor anything on the top over here? No, so I copy. And can I factor anything from the bottom here? If you notice, I can factor out of 5, so it'd be 5x divided by 5 is x, 15 divided by 5 is a 3. Okay, so I'm done with step number 1, which is I factored the top, I factored the bottom. Couldn't factor the top here, but I just copied and I factored the bottom. So now I'm ready for objective number 2, which is to cancel. I'm going to cancel the x plus 3. Also going to cancel the x minus 4. So I'm left with 10 on top, x minus 2, and a 5. But wait a second. Can I reduce 10 over 5? You bet. 5 goes into 5 one time. 5 goes into 10 two times. So that means on top I'm left with a 2. And on the bottom I'm left with x minus 2. And that's my answer. Okay, let's go ahead and proceed for the next problem. Okay. Alright, so again, our steps is first factor, second cancel. Always keep that in mind. Okay, and on this one it looks like everybody's going to be able to factor. So let's go ahead and see here. I have a 1 there, so what numbers give me a 1? It would be 1 and 1. So in other words, this would be x 1 1. Sign of the biggest, it would be positive and positive. So that means my first factor here is going to be x plus 1 times x plus 1. Then on the bottom here I have 18. What numbers give me 18? 1 and 18, 2 and 9, 3 and 6, and I believe that's it. So which one will give me a 3? And 3 and 6 give me a 3. So this would be x. So it would be 3 and 6. Sign of the biggest is going to be the same as the middle term, so negative. Negative 6 plus 3 or minus 3 is going to be a negative 3. The answer is a positive 3. So this would be x plus 3, x minus 6. Okay, and we're dividing. So, okay, this one here, I know I need to add I need to add a 0x, so it'll be x squared plus 0x minus 1. 1, right? So the numbers give me a 1 is 1 and 1, so it'll be x1, x1, so this would be positive and a negative. So I'm going to write over here x plus x minus 1, x plus 1. Okay, and then the last one is 6, so 1 and 6, 2 and 3. One numbers give me a 7, it'd be 1 and 6, so it'd be x1, x6. What is the sign of 6 going to be? It's going to be a negative. So that means the 1 it would have also to be a negative, because negative 1, negative 6, negative 1 is negative 7. Alright, so I have accomplished the first step, or the first objective, which is to factor. Now I have a division of fractions. So what I'm going to do is I'm going to copy the first fraction, x plus 1, x plus 1, x plus 3, x minus 6. Change that to times. Flip the second term. So that means the numbers on the bottom goes on the top. And whatever's on the top goes on the bottom. Okay, so I factored, I changed division to times, and I flipped. Now I'm ready to cancel. So when I cancel, let's see, I have x plus 1, x plus 1. I have the x minus 1, cancel with the x minus 1. X minus 6, cancel with the x minus 6. So what did not cancel on the top? The x plus 1. And what was not canceled on the bottom? X plus 3. So that's my final answer. Okay. Alright, let's go ahead and proceed with the last problem on this page. Again, let me write over here our objectives, which is to factor, then cancel. So, x squared minus 25, I want to add a 0x there. So this would becomes x squared plus 0x minus 25. And I go to the side of my paper here, and what numbers give me 25? 1 and 25, 5 and 5. Which one's going to give me a 0? 5 and 5. So I'm going to go ahead and write over here x5. Actually, let me write a little bit lower. There you go. x5, x5. Good. And one is positive, one is negative, because plus 5 minus 5 is going to give you a 0. Alright. Then I have this guy over here, and I notice this is not a 1, so that's going to take a few extra steps. First thing I do is 2 times 12. 2 times 12 is 24. So it'll be 1 and 24. 2 and 12, 3 and 8, 4 and 6, and that's it. And I'm looking for a number that will give me a 5. That number is 3 and 8. So, what do? I copy the first term, change this to 3x and 8x, and I copy the last term, which is negative 12. So that means 8 is going to be positive, and the 3 is going to be negative. Now I focus my attention on the first two, and then I'll focus my attention on the last two. And I try to factor. What do they have in common? Okay, in the first two I have an x that I can factor, so this becomes 2x minus 3. On the last two, put a positive. The number goes into 8 and 12. The answer is 4. So 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. So that means on the bottom of the denominator, I'm going to get 2x minus 3. And if I factor those out, I'm left with x plus 4. Okay. So basically, here's my first fraction, and I factor both top and bottom, and here's the new fraction. Okay, I'm going to take one step ahead, and I'm going to go ahead and divide and flip this. Okay, so I'm going to flip and make it times. I'm going to factor the one on top. I know that I have 10. What numbers give me 10? 1 and 10, 2 and 5. Alright. So what number gives me a 3? The 2 and 5. Okay, so that means this will become x. I'm going to put 2 and 5. Sign of the biggest is the same as the middle term, so this will be a negative. And negative 5 plus 2 is what gives me negative 3. So I'm going to take this, and remember we changed to times, and we're going to flip it so that those terms here are going to go to the bottom. And now I'm ready for the last one, which is 20. So one number gives me 20, 1 and 20, 2 and 10, 4 and 5. And which one will give me the 9? 4 and 5. So I come over here. This would be x 4 and 5. Sign of 5 is positive, and the 4 has also to be positive. So because we flip, this here is going to be part of the top, so we put it right there on the top. Okay, very well. Now I have finished factoring. I also went ahead and changed division 2 times, and I flipped the second term. So what was on the bottom went to the top, and what was on the top went to the bottom. Now I'm ready to cancel. Okay, I have an x minus 5 on the bottom, x minus 5 on the top, so they cancel. I have an x plus 4 and x plus 4. Okay. Now, a very common mistake that I notice is that a lot of students would cancel these two, but these two are both on top. You can only cancel if they're on top and the other one's on the bottom. Okay, because they're both on top, you cannot cancel. All you can do is write x plus 5 to the second power. Okay. On the bottom, I have 2x minus 3, x plus 2. And that's it. Okay, so let's go ahead and do the last problem now, which is problem number 15. Okay, we are not going to do the bonus question on the retake. There's not going to be a bonus question. So there's only going to be 10 questions. Okay, all right. Same thing again. Is we want to keep in mind our goals or steps, which is first we need to factor, and second we need to cancel. So when I approach this problem, I look at the first term right there and I ask, can I factor anything? And yes, I can factor 7. So that means 7x divided by 7 is x. 14 divided by 7 is negative 2. The next one, I notice off the bat that this is not a 1, so it's going to take a few more steps, but that's okay. 3 times 8 is 24, and I write, what numbers give me 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. And I ask myself, which one will give me a 10? Well, in this case, there's two options. There's a 2 and 12 and a 6 and 4. So the deciding factor is going to be the signs of the number. So what you have to do is put the signs over here. So let's see, 12, this would be a negative, and this would be a positive to give me a negative 10. And if I choose this one, this would be a negative, and then the 4 would be also negative. That will give me a negative 10. Now the question is, when I multiply these numbers, which one is going to give me a positive answer? Well, a negative times a positive gives me a negative, and here I have a positive. So that means that doesn't work. This next one is negative times a negative equals a positive, and that's what I want. So I know this is my pair of numbers. Something I noticed on the first test is that some students would write the first two numbers on the list and they notice, oh, 2 and 12 give me 10, and they never finish the list, and they don't see that they have a second option, and then they don't pay attention to the signs and ended up solving for this, and that's wrong. Okay, so please make sure you complete the list. When you finish the list, then look, how many options do I have that will give me the middle term? Sometimes you will have 2, and then you have to check your signs. Okay, and that's what happened here on this problem. Alright, so now we know it's negative 4, negative 6. So I'm going to copy the first term. I'm going to break down the middle term as negative 4x, negative 6x, plus 8. and we're going to factor the first two and the last two. So this will be, one number goes into 3x and 4x. The answer is x. So that means this will be 3x minus 4. I have a negative, so I put a negative. One number goes into 6 and 8. The answer is 2. So negative 6x divided by negative 2 is 3x. And 8 divided by negative 2 is negative 4. What can I factor from these two? I can factor 3x minus 4. And the next one I'm left with x minus 2. So here I'm going to write 3x minus 4, x minus 2. Change the division to times. Okay. And I'm going to flip this. Can I factor anything with 21x? No. So all I'm going to do is write the 21x on the bottom because you're flipping. And over here, this guy here is kind of funny because you expect the x to be in the front. So first thing I'm going to do is I'm going to flip the numbers there. Negative 9x I'm going to put on the front. The 12 is going to be on the back. And what can I factor from both of these? If I notice, I can factor out a 3. Okay. And also I notice that I have a negative 9. I don't like that negative in the front, so I'm going to go ahead and factor a negative, and that's going to fix the problem. Okay. That means this first number here is going to be a positive inside the parentheses. So negative 9x divided by negative 3 equals 3x. And positive 12 divided by negative 3 equals negative 4. So in other words, I took this guy and I factored to this. And when I go write it, remember, I switch the second term. So this is going to go to the top. Alright. So now I've accomplished the first step, which is to factor each one. I also accomplished the steps of division, which is I change the division sign to times. Okay, remember, I copied the first term, you change it to times, flip the second term. So now I'm ready for the final step, which is to cancel. When I went to go to cancel, I noticed x minus 2 cancels. The 3x minus 4 cancels. And basically what you can do is 7 times 3 is negative 21. And on the bottom I have 21x. And I now notice that I can reduce top and bottom by 21, so this becomes negative 1 over x. And that is our final answer. Okay, this concludes the corrections or the test review. Okay, I hope that these videos are helpful to you in preparing you for the retake. Remember, the retake, you can get up to 70 points. So it's a great opportunity for you to raise your grade. Okay, so please use these videos to review the steps, and I wish you good luck. Bye.